Okay, so if you kind of want to see where you fall in the course, the average, this was the breakdown of grades. 1A, 4Bs, 2Cs, 3Ds, and 3Fs. 67% was the average, but the median was 74, meaning half the class got a 74 or above. So the average meaning we just kind of have some of those low grades to bring us down. The answer key has been posted along with a blank exam. You go to the lecture and handout section in chapter 3, the bottom of, or sorry, chapter 4, the bottom of chapter 4. You will find both the exam and the answers. So we pull up the answer key here. And let's open it in OneNote so I can draw on it. So here's the exam. Some of you on the front page, most of you got the full credit. Some of you got down to this part and didn't know what to do to solve for y, or maybe this part. So that cost some points. 1 or 2 points maybe were lost with this, the third root. Does anyone have any questions on the first page? This is also on Blackboard, so you have access to it. It looks so. Yeah, looks good. Will, Devin. Number 3 and 4, not a lot of partial credit there. Should have been pretty straightforward. 5, graphing went fine for most part. Some of you guys, the domain, when range, you did some crazy things. Any questions on the second page? 6, some of you didn't put minus infinity to minus 5. So I kind of want to see this. And then x has to be greater than 5 or x has to be less than minus 5. So the domain here would be 2 intervals. Third page, this you should have gotten full credit because you could plug that in your calculator. You could hit log of 1 over 81 divided by log of 9 and get minus 2. Or you could say, what do I need to raise 9 to get 1 over 81? A lot of people miss this one. A half to the 0 is 1.
And then once I got it, I was like, oh, duh.
Yeah, and so you could have plugged in your calculator. So it was all or nothing on these 3 points each. Number 8, some of you did some things with this a squared plus b squared. You try to separate that more, you can't separate it more. And then I also took off a point if you didn't simplify log of 10. Nine, most of you on the take-home part got that right or left it blank. Factors of 72 are 2, 2, and 2. And 3 times 3, so 3 times log base b of 2 plus 2 log base b of 3. Log base b of 2 and log base b of 3 was given. Plug that in your calculator, you get 1.783. 10 really kind of came down to factoring problem. If you set up the ratio or you set it up as the top number divided by the bottom number with the square root. factored it, simplified, and got the answer there. Part A on number 11, there was 2 ways to go about it. And I think everyone on the take-home did this way, which is fine. There's a little faster way to know 4 is 2 squared. Solve for y, we get minus 7 over 3. Marcus, grab your test. Some of you went about it this way and lost a negative along the way, so your answer was a little off, and I try to give you partial credit for your work. Any questions on that page? The next page, there is 2 ways to go about it. I could take log base 5 of both sides and end up with log base 5 of 53 minus 3. Plug that in my calculator. Or I could just take log of both sides. And some of you did that and did fine. You end up calculating it the same way. And this, or I could take natural log of both sides, come out with this, plug it in my calculator, and get the same approximation. Right? Here, the answer is x equals 0, and I took off a point if you didn't put x equals 0, if you just put ln of 1. Maybe it was a little harsh, but there was 4 bonus points, so I didn't go back and give points back for having ln of 1 as the answer. So you do the u substitution, you get a quadratic, you know e to the x can never equal minus 8, so when is e to the x equal 1, and that's at x equals 0. The last page, the log problem here, we have log of x plus log of x minus 1 equals log of 12. I need to combine that into one log on the left-hand side. Since I'm adding them, if I combine the log, I multiply them. So at this point, I have log equals log, so I can drop the log and solve for x. I get 2 solutions, but one of those solutions doesn't work at minus 3. So x equals 4 is my only solution. And then the last one was very similar to the first one on number 11, except you can't do it a shorter way. You have to do natural log of both sides. Again, 1 or 2 of you dropped this negative here, and so your answer was a little off. Any questions on the exam? So today we're going to continue with 7.2, and I'll probably pull up Alex to show you guys some 7.1. I probably will. If I don't have it, you can find out Blackboard is turned off at a computer lab, but I will look. I threw them away. Sorry. I was. So let's look at last time on 7.1, we were talking about the ellipse, and there's really only 2 interesting things about it, and that's the distance in the x direction and the distance in the y direction. And we have the figure that can be, the major axis can be in the x, or the major axis can be in the y. And then corresponding the distance from the center to the major axis and the center to the minor axis, and then the focus points. And it doesn't matter if our center is at 0, 0, or if our center is shifted any HK. So we did some examples of that. And I want to pull up Alex and work through some of the Alex problems.
For some reason with Alex,
Mhm.
whenever I log on at school, it like says that my Alex whatever is like expired. Whenever I log on my house, it doesn't ever say that. It's kind of a problem because I don't have that card to sign in.
Yeah.
That code, you know, they have what's on the back of the card. You ever had that problem?
So at home, you're fine. You can do your homework. But when you come to school and you sign on, it tells you what?
It's like expired. I can buy a new card.
But it doesn't tell you that at home. I don't know. That's never happened.
I think it's
Are you using the same sign-in and same
Yeah,
login?
I only have one.
Yeah, I don't know.
I don't know. I just think that was.
That is weird. If you want after class, we can look and see what it says, and I can see. Pretty sure I can see if you are registered in your sign-in. So I don't know. We can play with it. What assignment is this? Let's start over. And it's in progress. Okay, we'll just start with this. Okay, so here's the example of how they are presented to you in Alex. It says graph, and it gives you the equation. Eventually, we're going to do other types of equations, and you're going to have to be able to identify this is a ellipse, or this is a hyperbola, or this is a parabola. So you're going to have to know the difference. But right now, this is the only type we know, right? Looking at this equation, what is my major axis? X, right? So my center is going to be 2 minus 2. So if I go to graph, picking the type of graph I want to deal with, first thing it wants to do is place the center. So I'm going to place the center at positive 2 for my x and minus 2 for my y. So if I click on that, and then it says place my vertex. My vertex are going to be my major axis. We said here, since the 9 is larger than 4 and it's below the x, my major axis is parallel to the x-axis. So it's going to be 3 units from the center, right? 1, 1, 2, 3. You guys see that? Then the 4 is under the y-axis, and that tells me I'm go 2 up. So I go 2 up from the center, and place that there. And is that all it needs? It doesn't even ask for focus points. You go to graph it. Here, it's going to ask you to graph it, so the first thing you need to do is put it in standard form. So going to how would I put this in standard form?
Add 900 to both sides.
I add 900 to both sides. So I'd have 25 x squared plus 36 y squared equals 900. Divide both sides by 900. What do I get? 25 over 900 equals, how many times will 25 go into 900? 36? Boom, 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 boom. What about 36 divided by 900? 25. How do you divide? 1, right? So this tells me A is 6 and B is 5. What's my major axis? The x-axis. Is there any shifts? There's the center is 0, 0. So going back here, my center is 0, 0. My major axis is the x-axis, right? And I go 6 units to the left and 6 units to right to get my vertices. I go 5 units up and 5 units down to get my vertices. So here, my center, I go 6, 5, and I get my graph. My focus point's going to be on the major axis, so they're going to be somewhere in here. They didn't ask for that in the graph. Next question. Along the same lines, here there's going to be a shift. Oh, I guess I got it. So, oops, let me get it. So here, I have to find the equation. So I need to do completing the square. So you guys will work on this one for a little bit. Remember, you want to group the x squared term, or the x's, group the y's, everything else to the right-hand side, complete the square, divide through by the right-hand side to get 1, and then find your x-axis and your y-axis distances and your center. A lot of students get disconnected from doing ALEKS problems and doing them written. So you want to convince yourself you could be able to graph this without ALEKS. Because ALEKS is kind of nice. This is the center, this is the distance, this is the distance. You have to come up with those points. Questions? This 4?
No, the 4 is minus the y.
This 4?
Yeah.
The 4 here, this is 4y squared. And I want the coefficient, because the way we learn kind of completing the square, we want that coefficient to be 1. So I'm going to factor out that 4. So I'm also going to factor out the 4 from the 32y. This is the 8y. did you watch? Did you have a chance to watch the seventh one? So we go over a lot of. So if you're convinced I did my math correctly, the first step to do is to find the perfect number that's going to make my x terms a perfect square. So I take 8 over 2 squared and get 16. And then I need to find the perfect term to make my y quadratic a perfect square, and it turns out it's 8 over 2 as well. Whatever I do the left-hand side, I have to do the right-hand side. So here I added 16, and here I added 16 times 4, so I have to add 16 times 4 to the other side. So adding those together, minus 76, I get 4. Dividing through by 4, I end up with this in standard form. So this tells me that I have a ellipse that shifted minus 4, minus 4. My x-axis is my major axis, and I go over a unit of 2. And my y-axis is my minor axis, and I go up 1 from that. You guys see that?
Why is your x-axis the major? Is it because the 4 is on?
Because the 4 is the larger number, and this would be a, and this would be b. And remember, it's always a squared, b squared. The general form is x minus h squared over a squared plus y minus k squared over b squared equals 1. So now if I plug this in, Alex, so I need to graph it. I go minus 4, minus 4, minus 4, minus 4. My my x-axis is my major axis, and I go 2 units to the right and 2 units to the left. And then my minor axis is my y-axis, and I go 1 unit up from my center there. And it gives me that graph. So this question asks for the focus points. So I need to find the general equation. So I need to complete the square. I pull out a 16. What do I'm left? 4 minus 4x plus, I pull out a 25 from my y squared terms. Oh, where's my other y at? None. I'm going to leave this 25 y squared. There's no other y term, right? Equals 336. So this is already a perfect square. Y squared is perfect. So what do I need to add to this quadratic? Minus 4 over 2 quantity squared, which is minus 2 squared, which is 4, right? So if I did it to the left-hand side, I have to do it to the right-hand side. And I didn't add just 4, I had 4 times 16. So whatever I did to the left-hand side, I have to do the right-hand side. Now doing that, I get a perfect square. I get 16 x squared, what, or not x squared, x minus 2 quantity squared plus 25 y squared equals a large number.
64.
Is it 64?
I think so.
6, 7, 8, 9, yeah, 400. Divide through by 400. 16 divided by 400, or 400 divided by 16? 25? 25, right? So x minus 2 quantity squared over 25 plus y squared over 16 equals 1. So this tells me A is 5 and B is 4. So how do I find C? Yeah. C squared is A squared minus B squared. So C squared is 25 minus 16. So C is plus or minus 3. In this case, we'll just say 3. Right? So what is our center? Minus 2, 0? 2, 0. Right? So I can put my center anywhere, 2, 0. Which is my major axis? The x, right? So the distance here, C units, is going to give me my focus points, right? So x is changing by 3. So what is this point? 2 minus 3? Minus 1 comma 0. And this point would be 5, 0. Right? That's my focus points. They're on my major axis, and they're C units from my center. So my center here is 2, 0. I go C units to the left and C units to the right. That only affects x. My y stays the same at 0. So minus 1, 0, and 5, 0. Minus 1, 0, and 5, 0. Let me hit the next question. Find the equation of a ellipse that has a center 4, 4, minor axis length of 4, and a vertex at 4 minus 8. So if we can visualize what's going on here, the center is at 4, 4. So this would be x minus 4 squared, y minus 4 squared, right? The center. So if I put 4, 4 here, the minor axis length of 4 and a vertex at 4, 8. So 4 minus 8, 4 minus 8, right? So that tells us our major axis is the y-axis because the x is the same, right? So this is a distance of 12, right? Right? So if I go a distance of 12 up here, I also get my other vertice, but I don't need that. I just need to know that this is 12. This corresponds to A, because that is the distance of my major axis. From the center to the vertice, the distance of 12. So that would be under here, 12 squared. Right? The minor axis has a length of 4. So this would be 4 squared. So you see how I kind of break that down into what I know, the center, which is being shifted, AB. Sorry, not AB, HK. Given the other vertex was at 4 minus 8, this is a distance of 12. That tells you what A is, and A is always under the one that has the major axis. So I know that this is going to be the y-axis, or under the y term. So this would be 64, this would be 144. So we want the equation. So I have x minus 4 x minus 4 squared divided by 64? 16? 4 squared. Is that right? 64. Another page. Here I have y minus 4 squared over, what was it? 44? 44? 144 equals 1. Guys agree with that? Sure, we'll see how the grading goes at the end. So here again, the same kind of setup. They're asking for the equation, having a major axis of length 12, and given the focus points. So minus 3, 5. So if I push this here, this is minus 3, 5, and minus 3, minus 3. So that tells me my major axis is the y-axis, right? Because the focus points are on your major axis. My center is somewhere in between here, right? Let's put this at, my center has to be in here somewhere, but I know this whole length is 12. Right? So that tells me half the length is 6. So that tells me A is 6, then tells me C is, what's halfway between, or what's the distance between 5 and minus 3? 4, right? 8. Well, yeah. This is a distance of 8.
Yeah.
So C is 4, right? If they're 8 distances from each other, then half of that is 4. So C would be 4. So C squared is A squared minus B squared. So 4 squared is 6 squared minus B squared. So B squared is 6 squared minus 4 squared. Move 6 squared minus 4 squared. 36 minus 16. 20. So B is the square root of 20. Right. So we have A, we have B. Do we have the center? What is the center? Minus 3, 1. So I have x plus 3 quantity squared plus y minus 1 quantity squared equals 1. The y-axis is my major axis. 6 is under 6 squared, and this would be 20, the square root of 20 squared. So my answer here would be x plus 3 quantity squared over 20 plus y minus 1 quantity squared over 36 equals 1. You guys see that? So I get in here, oops. Setting this up, I have, what was it, x minus 3? Was it y minus 1? I forget. X plus 3, y minus 1. 20, 36. Submit that. Graded. Maybe too wrong. Oh, it was 4 squared. Or was, what was this one? It was just 4, not 4 squared. What did I do there? It says the minor axis length was 4, which was just given there. The minor axis length would actually be, the distance from the center to the minor axis would be 2, right? 4 squared is not 64 anyways, it's 16, but it would just be 4 here, right? When it gives you the minor axis length, that is a squared or b squared. If it just gives you the center to the outside, then you have to square it for a or b. So that was the only one we missed here. Does anyone have any questions on these?
How do you find A and C?
A, c squared is always a squared minus b squared.
If you want you to write a equation.
How do you find it?
Yeah.
Okay, so let's just kind of look at this. If I have a center here, right? And let's say I give you this distance, or you find this distance. If this is A, and this becomes your major axis, because A is the distance from your major axis, B is the distance from your minor axis, C is the distance from your center to your focus point. So in this case, it would be x squared over b squared plus y squared over a squared equals 1, because A is always the larger one. And you always take c squared is a squared minus b squared. So so we didn't quite get to um, 7.2 today, but we'll have time to look at 7.2. I want to open this real quick. On 7.2, we're going to look at the hyperbola, and a hyperbola looks very, very similar. Look at this. This formula is very similar to what we've been dealing with, right? Except it's not adding, it's subtracting. Right? So if we change the sign in front of either the x or the y, we don't get a ellipse, we get a hyperbola. And a hyperbola either opens left or right or up and down. And there's going to be some things we're going to look at here. We're going to have a center. And then from our center, A units from our center is going to be our vertex. Right? And depending on it, it's always A here. And A is always under the positive coefficient in front of x or y. So looking back here, you can see that the x term is what's paired with the negative, and here it's the y term. So A is under the positive term. If the positive term is x, that means it opens left or right. In the center, A is the number that's from the center to the vertex. And it's going to open left or right. If A is under the y term and the x term is negative, then I open up or down, but A is still this distance here, right? It's just now on my y-axis. And of course, we're going to take this and we're going to shift it anywhere in space, HK. The things we'll focus on: the center, the vertex, and the focus points. So we'll have a center, we'll have the vertex, and we'll have the focus points, and the focus points are always on the line parallel to the x-axis or the y-axis, depending on if it opens up and down or if it opens left or right. And then the last thing, which probably be the most difficult, is the asymptotes. In terms of the center being 0, 0, the asymptotes are B over A. Plus or minus B over A. Or plus or minus A over B. And it's relatively easy to find because you find rise over run. So the equation is pretty straightforward, except when we shift the point. So then we have to do point slope form, the equation of a line, to get those two formulas. So we'll go over this on Monday, how to go about it. Go ahead and try the first two. If you have time to kind of try that, and then we'll hit those again. Really what we're going to focus a lot of our time on is the shifting. Because if there's any shifts, it makes finding the equation of the asymptote just a little harder because we have a point and a slope, and we have to go to point slope equation of the line. If you guys recall, y minus y1 equals the slope x minus x1. So given a point and a slope, we have to plug it in this formula. When our point is 0, 0, it's really easy. But when our point is anything other than 0, 0, then our slope here, we have to plug it in the equation of the line. But that's the only thing different. Eventually, you're going to have to classify, is just looking at the equation, is it an ellipse or is it a hyperbola? If one of them is negative, it has to be a hyperbola. If they're both positive, and it's an ellipse. Find A, find C, so forth. Another thing your book does is they call the focus C as well, but this time C squared is A squared plus B squared. Where last time C squared was A squared minus B squared. But it turns out it ends up making sense here, and we'll talk about that on Monday. All right, any questions? All right, I'll see you guys on Monday. Good weekend. You too.